Welcome to another episode of 10 Minute Philosophy, the show that's bringing the tools of critical thought to the 21st century, 10 minutes at a time. According to my to-do list today, we're defining terms, and the word of the day is logic. Now, this episode's actually the second part of the definition of logic. If you haven't watched the first episode, just push the old pause button and go check it out and come back. You'll thank me. For those of you who have watched the first episode, welcome to what is easily the most anticipated episode of 10 Minute Philosophy yet. And that's really saying something, since at the time of this video's recording, 10 Minute Philosophy is like almost a whole week old, so, wow. Anyways, in our last exciting episode, we learned all about Aristotle's idea about how to develop a system for assessing truth claims that's centered on the classification of declarative statements and how they relate to one another. The system that Aristotle invented is called logic, and the specific device that we were learning about in the last episode is called the square of opposition. We're also going to be building on a metaphor that we introduced in the last episode involving Russian nesting dolls. So, seriously, if you didn't watch the first episode, you've got to go check it out. Alright, so Aristotle tells us that there are four types of declarative statements: universal affirmative, universal negation, particular affirmative, and particular negation. And he labeled each one A, E, I, and O, respectively. So, a universal affirmative would be something like all X are Y, and a universal negation would be no X are Y, and a particular affirmative would be some X are Y, and a particular negation would be some X are not Y. Got it? Alright, so A and E are said to be contrary, because assuming that we're talking about the same X and Y, then A and E can't both be true at the same time. Also, I and O are said to be subcontrary, because, again, assuming that we're talking about the same X and Y in each case, I and O can both be true, but they can't both be false. Alright, now, in addition to that, I is a subaltern of A, and O is a subaltern of E, meaning if A is true, then I has to be true, and if E is true, then O has to be true. Okay, now if we crisscross, we'll also get contradictions, because if A is true, then O can't be true, and if E is true, then I can't be true. And that's it. This is the square of opposition. Okay, we're going to take this as our touchstone, and we're going to build on it. Okay, so now let's apply this idea to a few examples and see if we can dig a little deeper. Alright, so the first step is to realize that all statements, A, E, I, and O, share a similar structure, and that structure is just basic grammar. Every full sentence has a subject and a predicate. So in our example, let's make the green doll the subject and the red doll the predicate, and we'll also use the variables X and Y. Alright, so going down the list, all the green dolls are in the red dolls. That would be A. E would be none of the green dolls are in the red dolls. Okay? I would be some of the green dolls are in the red dolls, and O would be some of the green dolls are not in the red dolls. And yes, I and O are really just two ways of saying the same thing, but you're going to need both of them because different circumstances will give you access to different levels of information. And you may not have access to all the information when you're trying to assess a truth claim, so the I-O distinction will allow you to focus in on whatever it is you do have access to. Okie dokie, artichoke. Let's go back to our central metaphor with the nesting dolls. Now say that I tell you that the green doll is inside the red doll, and then I tell you that there's a blue doll that's inside the green doll. Now with that information, you know that if both the statements are true at the same time, then there must be a blue doll inside the red doll, even though I never actually said that there was. This is because, according to Aristotle, you're able to determine the relationship between the red doll and the blue doll by mediating it through the relationship that they share with the green doll. So let's put all of our dolls away and plug this framework into language. In the situation that we've laid out here, the green doll is the subject of the first sentence, and the red doll is the predicate. In the second sentence, the blue doll is the subject of the sentence, and the green doll is the predicate. And these two sentences together give us our third sentence, namely that the blue doll is inside the red doll. Notice also that the subject of the second sentence became the subject of the last sentence, and the predicate of the first sentence became the predicate of the last sentence. So let's go ahead and label all this stuff. So the subject of the last sentence is what we call the minor term. And the predicate of the last sentence is what we call the major term. The term that does not show up in the last sentence, the term that doesn't show up in the conclusion, the green doll, is what we call the middle term. And it's what the conclusion is mediated through. So the middle term never shows up in the conclusion. You should also notice that each term gets used exactly twice. So the minor term shows up in the second sentence and in the conclusion. The major term shows up in the first sentence and in the conclusion. And the middle term only shows up in the first two sentences. So we call the first sentence the major premise because it has the major term in it. The second sentence is called the minor premise because it has the minor term in it. And the last sentence is the conclusion. You'll also remember from the first episode that these first two sentences are immediate inferences, whereas the conclusion is a mediated inference. Alright, so according to Aristotle, this simple structure is the building block of all of reason. And so we call this atomic unit of reason a categorical syllogism. And every categorical syllogism will consist of three statements, each consisting of a subject and predicate pair. And the three statements will consist of three terms, each used exactly twice, such that the first two statements build the relationship that makes the last statement work, if it's correctly constructed. Okay, now recall also that each statement has to be one of the four possible types of statements, meaning that each statement has to be an A, an E, an I, or an O type of statement. So if we take those three letters and use them to identify the statements in the argument, we can determine what's called the mood of the argument. And by the mood, we just mean that what combination of statement types the categorical syllogism is made out of. Alright, now there's 64 possible moods that you can come up with if you mix and match all the possibilities long enough. Alright, you with me? Alright, looking good. Okay, now this next step, unfortunately I have a little confession to make. Earlier when I explained how the major and minor premises worked, I made it look kind of simple. Unfortunately, I'm a dirty rotten liar because it's actually a lot more complicated than I made it out to be. So the good news is that the predicate of the conclusion will always be in the first sentence. And the subject of the conclusion will always be in the second sentence. The confusing part is, well, for example, the subject of the conclusion may not be the subject of the second sentence, the minor premise. It could be the predicate, or the other way around. So let's switch the subject and predicate to the variables x and y so we can tease this out. Alright, so the last part of the conclusion, the predicate, will always be in the first statement, the major premise, but it may not be the last part of the sentence. It could be in either place. Similarly, the first part of the conclusion will be in the second statement, or the minor premise, but it may not be the first part of that statement either. It could be in either place. So that looks frustrating, right? But the trick here is don't chase around trying to find the subject and predicates. Instead, just focus on trying to find the middle term and locating where the middle term is in the first and second premise. So the middle term, or the middle terms, can end up in four possible positions, and we call these figures 1, 2, 3, and 4. Pretty easy, right? Alrighty then, so we've got 64 possible modes and 4 different figures. So 64 times 4 equals 256. That means there's 256 possible categorical syllogisms, 256 possible arguments, which I kind of sorted and listed out here, but I ran out of room and it's also kind of boring to write them all out, so you get the idea. But the question you're probably asking you right now is why? Why, for the love of Vulcan, why would you ever want to learn all this crap? Well, if you're willing to learn just 5 more rules, you'll discover that there are 15 unconditionally valid argument forms. 15 arguments that, if the premises are true, the conclusions absolutely have to be true. There's also 9 conditionally valid argument forms that, under certain conditions, will always be true. And if you're willing to just drill through to get those last pieces, then you can rock it like Spocket. But unfortunately, we're going to talk about all that next time because we're running out of time. If you really want to know about the 5 rules, I would highly recommend visiting our friends over at carnades.org. I put a link down in the doobly-doo to some of the videos that they've created explicitly explaining the 5 rules. and how you can use them to filter out all the fallacious arguments and get down to some brass tacks logic. Other than that, we'll pick up this discussion in our next episode about logic. As always, thanks for watching. If you wouldn't mind hitting that subscribe button on your way out, I'd appreciate it. And we'll see you next time. Keep on thinking.